displacement right side, force is upward, then what is the work done? 0. So when force is perpendicular, work done is 0. In circular motion, uniform circular motion, what is the direction of force? And uniform circular motion, what is the direction of force? Tell me. What is the direction of force? Towards center. Very good. Direction of force is towards center. When particle is here, the force is acting towards center. When particle is here, force is acting towards center. When particle comes here, the force is acting towards center. But what is the direction of velocity? Velocity, tell me, velocity? Tangential. Velocity is tangential. When particle is here, this is velocity, this is force. So always velocity and force, what is the angle? 90 degree, correct? So uniform circular motion, in uniform circular motion, work done by centripetal force, is 0 or non-zero? 0, because force is acting in which direction? Perpendicular to velocity. So if you see small displacement, for a small displacement, very small displacement like this, small displacement. So force is this. This is displacement, this is force. If you see small displacement here, this is the displacement, this is the force. So force and displacement are perpendicular. So work done is 0. So note down. Work done by centripetal force, work done by centripetal force is 0. Note down. Yes, yes. Note down. What is the work done by centripetal force? 0. Okay. Work done by centripetal force 0. Remember this. Okay. Why? What is the reason? Why? Because centripetal force and velocity are perpendicular. Centripetal force and velocity are perpendicular. Centripetal force and velocity are perpendicular. Right? Work done formula is Fs cos theta. Fs cos theta. Fine. So when angle is 90, work done is 0. Non-uniform circular motion. Non-uniform circular motion. What is non-uniform circular motion? Speed changing. Good. Speed changing. Remember. Uniform circular motion means speed constant. Constant speed. Like circular motion of moon. Moon is performing circular motion with constant speed around Earth. Electron. Electron is performing circular motion with constant speed. But non-uniform circular motion means speed is changing. Speed is changing like this. Slow speed, now speed increasing, like this. Speed increase like fan. So when you switch on fan, what happens to speed? Increases. When you switch on the fan, speed increases. Now suppose already fan is running. Now you switch off. What happens to speed? Decrease. Final 0. Okay. So both are non-uniform. Non-uniform circular motion means speed changing. Changing means increasing or decreasing. So how many forces in circular motion? Two forces are there. One is centripetal force, another is tangential force, correct? Tangential force. Non-uniform circular motion, speed is changing. So which force is changing speed? Tangential. Okay, note down. This is tangential force. Tangential force. Tangential. The force along tangent. Force along tangent is tangential. Force towards center is centripetal. Okay. The name is given based on how they are. Correct or not? How is the force? If it is along tangent, so tangential force. If it is towards center, so centripetal force. Okay. So this is centripetal force. Centripetal force. Okay. Centripetal force. So suppose velocity is also anti-clockwise. This is anti-clockwise. Okay. This is clockwise. This is clockwise, anti-clockwise. So suppose velocity is also like this. So force and velocity are parallel, same direction. So tangential force is doing positive work. So speed will increase. Speed will increase because work done is equal to change in kinetic energy. If work done is positive, if work done is positive means kinetic energy increasing. Kinetic energy increasing means half mv square increasing. If half mv square increasing means v increasing, speed increasing. If work done is positive, so tangential force and velocity parallel, same direction, same direction. So speed increases, correct? Speed increases, work done is positive. So tangential force is doing positive work. Tangential force is doing tangential force is doing positive work when speed is increasing. Okay. So circular motion, non-uniform circular motion, non-uniform circular motion. Speed increasing, so tangential force is doing positive work. Centripetal force not doing any work. Okay, clear? If speed decreasing, what is the case? If speed decreasing, opposite. Very good. So they are opposite. So they will, like for example, this is the force. This is tangential force, and velocity is opposite. Velocity is clockwise. So in this case, speed decreases. Speed decreases. Okay. So because work done by tangential force, is negative. Okay. Work done by tangential force is negative. So three types of circles we have seen: uniform circle, circular motion. So uniform circular motion, only one force is there, that is centripetal force. Velocity perpendicular, fine. So work done 0. Work done by centripetal force 0. Speed is constant. Kinetic energy is also constant. This is increasing speed. Increasing speed means tangential force, velocity same direction. Work done positive. Work done by tangential force positive. Work done by centripetal force 0. Always 0. Work done by centripetal force is always 0. Remember, work done by centripetal force is always 0 because it is always perpendicular to velocity. This is negative work done by tangential force. Centripetal force 0 work. Okay, fine. Now we have formula work done is equal to Fs cos theta. When to use this formula? When to use? When force is constant, note down. Force is constant. Remember this. When force is constant. Force is constant. Okay, remember this. Fs cos theta. So when force is constant, remember. Okay. When force is variable, we cannot use this. I will give one example. You will understand this. Fs cos theta, what is the condition? Force is constant. It should not change with time. It does not change with time. It does not change with position. Okay. It does not change with position. I will come to this later. Okay. What do you mean by change with time or change with position? I will explain this. Okay. So first of all, you remember it is constant. Force is constant. Force is constant. Suppose force is 1 Newton, constant 1 Newton. Initial velocity 0. Mass is 1 kg. I am asking find work done in first 2 seconds. Find work done in first 2 seconds. Calculate. How to calculate? Initially at rest, mass is 1 kg, force is constant 1 Newton. So calculate acceleration. Read the question carefully. Force is constant, initial velocity 0, mass is 1 kg. I am asking work done in first 2 seconds. So how will you do it? First you calculate acceleration. How to calculate acceleration? F by m, 1 by 1, acceleration 1. Now displacement, calculate displacement. How to calculate displacement? S is equal to ut plus half at square. Very good. U is 0. Initially at rest. Initially at rest. Initially at rest. So u is 0. Half into 1 into time. First 2 seconds. 0 to 2. First 2 seconds means 0 to 2. So total time is 2. Okay. This is time duration. This is time duration. So 2 is square. So what is the displacement? 2 meter. So what is the work done? Fs cos theta. Okay. So you see, when initially object is at rest, initially rest. So where is the force? Right side. So displacement is also right side. Like suppose what is the initial? What is the velocity now? 0. So why it is going down? Because force is downward. What is that force? Gravitational force. Correct? Gravitational force. So what is the displacement? 2 meters. So what is the work done? Use this Fs cos theta. F. Work done is F S. Cos theta is 1. So answer is 2 joule. Correct? Answer is 2 joule. So that is constant force. Constant force means you can use this formula. Okay, let's give another question now. So now I am not giving force. In this question, what is given? Force. But now I am not giving force. I am giving x. X is equal to 2t square. X is equal to 2t square. So what is this? X is equal to 2t square means what? Relation. If you change the time, x will change. Okay. Time 0 means what is x? 0. After 1 second, what is x? 2 meter. Very good. So position is changing. Position changing means particle is in motion. Particle is moving. So calculate velocity, differentiate. 4t. Very good. Now calculate acceleration. 4. Very good. Now suppose mass I am giving 1 kg. Mass is 1 kg. Mass is 1 kg. And I am asking Find work done in first 2 seconds. Find work done in first 2 seconds. X is equal to 2t square. V is 4t, A is 4. Okay, differentiation. So work done in first 2 seconds. So again you see acceleration is constant. Acceleration is constant. So what is the formula for force? Mass into acceleration. Mass is 1. Acceleration is 4. So how much is force? 4 Newton. So you can use again you can use Fs cos theta. Okay, Fs cos theta. So force is 4. Now calculate displacement. How to calculate displacement? Again you can use ut plus half at square. What is initial velocity? If you put time 0, what is initial velocity? 0. So 0 plus half a 4 time first 2 seconds 2 square. So 8 meter. So 32 joule. So work done is 32 joule. Right? So how to solve this question? Suppose x is given 2t square and I am asking work done in first 2 seconds. Okay, you can, this is one method. One more method is there. Change in kinetic energy. Work done is also equal to change in kinetic energy. Now, what is final kinetic energy? Tell me. Final speed. First, you tell what is final speed. 0 to 2. Put 2 here. 8. Very good. So 4 into 2, 8. What is initial velocity? At 0. At 0, what is 0? 4 into 0. 0. Now change in kinetic energy means half m, mass is 1, final speed square minus initial square, correct? So 64 by 2. So 32 joule. Okay. Understood? So change in kinetic energy. So two methods you can use, but I will suggest use this. This is better. Okay. This is just one step. If you are using this formula, no need to find acceleration. No need to find acceleration. No need to calculate force. No need to find displacement. Okay. Just V, you know what is V? 4t. 4t. Just substitute first 2 seconds means 0 to 2. So final speed, initial speed, change in kinetic energy. Okay, clear? So use this. Okay, now I will give 2t cube. Third question you write. Third question. X is equal to 2t cube. Mass is 1 kg. Find work done in first 2 seconds. Find work done in first 2 seconds. So now you tell how to solve this. Now which method you are using? This first method or second method? So second method. First method you cannot use here. Why? Because acceleration is not constant. See, what is the velocity here? 6t square, and what is the acceleration? 12t. Acceleration is 12t, so force is equal to ma. So force is 12t, so it is variable, not constant. So force is variable. So Fs cos theta we cannot use. Fs cos theta not applicable. Okay, you cannot use. Fs cos theta fail. No. Okay, so don't use this because acceleration is not constant. So this is always you can use. Whether force is constant or variable, this is always true. Okay, work energy theorem. Work done is equal to change in kinetic energy. Always you can use. So 0 to 2 seconds. 0 to 2 seconds. So what is the initial speed? Use this formula. Speed. What is the initial speed? V1. If you put t equal to 0, what is V1? 0. If you put t equal to 2, what is V2? 6 into 2 square. Okay, 6 into 2 square, so 24. Okay, so final speed is 24. Final speed is 24. Now question 3. This is question 3. Final speed is 24. Now you use kinetic energy change. Change in kinetic energy half m v2 square minus v1 square. Okay, use it. So half v2 square is 24 square minus 0 square. 24 square, you know, 576. Very good. 576. Up to 25 you memorize. Okay. Up to 25 square. Remember. So 288. Correct. 288 joules. Okay. 288 joules. So this is the case. Okay. Clear. So whether force is constant or variable, this is always possible. Always this is clear. Okay. Always you can use. Now two statement I am saying, you would say true or false. Work done is equal to Fs cos theta is applicable in all cases. True or false? So false. Work done is equal to change in kinetic energy is applicable in all cases. So this is true or false? True. This is true. Okay. This is true. Okay. Fine. Okay. Fine. Good. Okay. Done. Now let's go back to spring and all. Okay. Basically, see, work power energy. You have two forces only: gravitational force and spring force. Okay. Gravitational and spring force. Okay. Fine. So let's continue with spring and gravitational force. So yesterday, first you understand gravitational force again. So work done by gravitational force. Work done by gravitational force. Gravitational force. What is the direction? Mg. Downward always. Where the particle is going horizontal, particle is going vertical, down, up, vertical down, okay, or in circular motion like this. Mg is always downward. So level you see, suppose this is the present level. Initially particle in this level, and finally it is in this level. So you just calculate h, whether particle going like this, okay, or like this. Okay, the path can be anything. Random path. You see the level. So what is the work done by gravity in this case? Minus mgh. What is the direction of force? Downward, and displacement upward. Correct. So work done by gravity is minus mgh. The path can be straight line, it can be random path, it can be inclined like this. Okay. Vertical you see only, vertically how much? Similarly, this is the initial level, like this. This is initial level, this is final level. So now this is the initial level and now this is the final level, and they are separated by distance h. Now you tell me, what is the work done by gravity? Particle is going from here to here. what is the work done by gravity? Plus or minus? Plus. Okay, because force is downward, displacement is also downward. In this case, force is downward, displacement is upward. So work done by gravity in this case, same direction. So plus mgh. Okay, clear? Understood? That's it. So work done by gravity is just remember, work done by gravity will be minus mgh or plus mgh. Remember. Okay, near Earth surface. This also you remember. This is near Earth surface. Earth surface. This is Earth surface. Ground. This is Earth surface. But if you go very high, 1 kilometer, 2 kilometer, 100 kilometer, 200 kilometer, then this is not applicable. Okay. Near Earth surface means you can say up to 10 kilometer, up to 10 kilometer height. After that, more than 10 kilometer, then we don't discuss all these. There is a separate chapter for that. What is that chapter? Gravitation, correct. Okay. So when height is more, then we cannot use this. Up to 10 kilometer, like we are on Earth's surface. Normally, what we see, apple falling, ball coming, correct? Something you throw, coming down. Okay. Water dam is there. Dam is not very high. Dam is also height is not very large height. Okay. Dam is less height only. So we for dam also we can use this formula mgh. Okay. If more height is there, we have to consider next chapter. Okay, fine. So, okay, fine. So this is mgh and minus mgh. Next, spring work. Let's make it simple. Okay, don't consider it as a complicated thing. Spring is very easy. Just think easy way. First, you memorize the formula. Okay, what is the formula for spring work? Minus k by 2 x2 square minus x1 square. Okay, let's solve two numericals. Let's solve two questions. Write down. First, you understand the meaning of elongation and what is natural state. This is the natural state. Do you see any force here? No. So here also force is 0. Right end no force, left end also no force. So this is known as natural state, relaxed state. Okay, this is known as relaxed state. Now you are holding it here and moving it right side. Left hand is fixed here. Left hand is fixed. Now the spring will elongate like this. Okay, the spring will elongate. Now you see the length of the spring is more. Suppose initial length is 1 meter. Now the length is 2 meter. So how much elongation? 1 meter. 2 minus 1. Elongation means increase in length. Elongation means increase in length. Like rubber band. You see rubber band. Suppose this is the rubber band. You hold the rubber band here and you move it. What happens to rubber band? Stretch, correct or not? So this is known as stretch, elongation, stretch. So length increases. Original length, natural length. What is natural length? 1 meter. What is the new length? New 2 meters. So what is the elongation? 1 meter. So that is known as x. This is known as x. Okay. So when elongation is x, so elongation. So spring force will act towards spring. This is the spring force. What is the formula for spring force? What is the formula? Magnitude kx. Okay, k is a spring constant. K is a spring constant. Okay, spring constant, or you can say force constant, or stiffness. This is also known as stiffness. Stiffness. So spring is very stiff. Stiff spring. What do you mean by stiff spring? not easy to stretch, very tight, okay, stiff, not easy, not easy to stretch, that is known as stiff, okay. Other what is the opposite of stiff? Like K is more, K is large, okay, K value is large, it is stiff. Less stiff means K is less, okay, fine, okay, clear. Now you see this, you are elongating the spring, you are holding this right end and you are moving it like this. So you have to do work, you have to do work because you have to exert force. So what is the direction of your force? Right side, opposite to spring force. This is known as external force. This is known as external force. So what is the direction of displacement? Right side. So external force is doing positive work, correct? And spring force is doing negative work. So we have a relation, external work done is equal to minus of spring work done, right? External work done is equal to minus of spring work done. Okay, fine, clear. So solve these numericals. Okay, solve. Spring of force constant 100 Newton per meter is elongated by 1 centimeter. Work done is W1. Now it is further elongated by extra 1 centimeter, extra 1 centimeter. Extra work done is W2. Find W1 and W2. Okay. First you understand this. So remember the formula for spring force minus K by 2 x2. x2 means final elongation, x1 is initial elongation. Okay. You understand this. Final initial elongation. Okay. x2 is in maybe in your books. In your books you will see this formula, K by 2 x1 square minus x2 square, both are same. If you take minus inside, it will be x1 square minus x2 square, correct? Okay, fine. So same thing only. So minus K by 2 x2 square minus x1 square. So solve this question now. Calculate. So to calculate work done W1, for W1 you tell me what is x1. 0. Very good. So initially it is relaxed. Okay, it should be given in question. Spring initially relaxed. Spring initially relaxed means natural state. Spring initially relaxed. So what is x1? 0. Now it is elongated by 1 centimeter. So what is x2? 1 centimeter. So 10 raised to minus 2. So calculate work done. Calculate and tell what is the answer. What is the answer? So W1, for W1 tell me, for W1 minus, correct, minus K by 2 x2 square 10 power minus 2 square minus 0 square. So minus 100 by 2 into 10 raised to minus 4. So this is 50 into 10 raised to minus 4. Then you can write like this, minus 50 divided by 10,000. So 1 0 cancel. So this is 5 by 1000 negative. Okay. So minus 0.00 5 joule. You can also write minus 5 millijoule. Okay, millijoule, minus 5 millijoule. Okay, clear? For second work done, what is x1? 1 centimeter. Very good. And what is x2? 2 centimeter. x2 is 2 centimeter. Okay. So initially spring is relaxed. Initially spring is relaxed. Next it is elongated. It is elongated by 1 centimeter. And next it is further elongated by extra 1 centimeter. Extra elongation is 1 centimeter. So what is a new elongation? 2 centimeter. Okay. 0 elongation, 1 centimeter elongation, 2 centimeter elongation. Okay. So here to here W1, here to here W2. Okay. When you take from 0 to 1 centimeter, it is W1, and 1 centimeter to 2 centimeter elongation, it is W2. Correct? Fine, good. So W2 will be minus k by 2, 4 centimeter whole square minus 1 centimeter whole square. Centimeter square you can take common. So minus 50, what? 2 centimeter. Yes, yes, correct. Okay, good. 2 centimeter square. Two centimeter whole square. So 4 minus 1 centimeter square, which is 10 raised to minus 4. So minus 50 into 3 into 10 raised to minus 4, and 50 into 10 raised to minus 4 is 5 millijoule. 5 millijoule negative, minus 5. So this will be minus 15 millijoule. Okay, minus 15 millijoule. So this is the work done. Okay, fine, good, done. Spring work done, that's it. Okay, no need to think much. Now yesterday we discussed one more question. This is the basic question. Here spring is there, initially relaxed, block is coming right side with velocity v naught. Spring is initially relaxed, correct? So block is coming on a smooth surface, frictionless. On frictionless surface, block is coming, right? So it will, what it will do, the block, what it will do, tell me. It will compress, very good. So it will compress the spring. Now the block is here. So initially the left end is here. Finally, where is the left end of the spring? Here. So this is the compression. This is the compression. Okay. This left end is here. Now the left end is here. Right end is fixed. Right end is fixed. Right end fixed. Correct. So left end is shifting right side by x. So by that time speed becomes 0. Why speed 0? Tell me. Why speed is 0? Because of spring force. When the spring is compressed, what is the direction of spring force? Here, left. So when block is coming like this, spring force is here. So, okay, opposite direction. So that's why speed is decreasing, final speed 0. Now you can use work done is equal to change in kinetic energy. So who is doing work here? Which force is doing work? Spring force. Mg is doing any work? No. Normal force is doing any work? No. Normal is not doing any work. Mg is not doing work. Spring force is doing work. Okay. Displacement is right side, spring force is left side. Spring force is constant or variable? Variable force. Very good. Spring force is variable force. It depends on x. Spring force is equal to kx. Okay, it depends on x. So we cannot use Fs cos theta. We cannot use Fs cos theta. Okay, so use this. So work done is equal to minus k by 2. Final compression square minus initial compression square. Initially relaxed is equal to change in kinetic energy. So half m. What is final kinetic energy? 0. Final speed 0. Initial speed v naught square. Correct? Like this you solve. So minus k by 2 x square is equal to half m into minus v naught square. Okay. So minus minus cancel, 2 to cancel. So kx square is equal to m v naught square. So what is x? Square root m by k into v naught. Understood? And what is v naught? What is v naught? Square root k by m into x. If final compression is given, you can find initial speed of the block. If speed is given, you can find compression. Okay, okay, fine. So this is done. So speed is decreasing. Okay, remember, up to here it is constant speed. Up to here it is constant speed. The moment it will hit the spring, the speed will decrease, 0. But permanently not here. Block is not permanent here. Again spring is pushing it. The block will again come left side. Speed will increase. Speed will increase, and ultimately the spring come to natural state. And block will go where? Left side. With what speed? V naught. Then block will go. Okay, clear? Understood? It will go left side. Okay, clear? Understood. Okay, very good. Okay. So keep revising. Okay, no problem. So, okay. Note down. So fine. Now, few more points we'll discuss. So spring, the potential energy. Yesterday we discussed about potential energy. So potential energy. So kinetic energy. Kinetic energy is due to motion. It is due to motion. Like suppose there is a bus. There is a bus, and driver is sitting. This is the driver. Okay, it is driving, and this is the passenger. Driver, passenger. What is the kinetic energy of driver as seen by passenger? Passenger and driver. Passenger and driver. What is kinetic energy of driver as seen by passenger? Tell me. 0. Very good. It is 0. But suppose outside person is there, ground person is there. Outside person will see the bus is going, so driver is also going. For outside person, what is the kinetic energy? 0 or non-zero? Non-zero. So note down. But for outside person, kinetic energy is not 0. Okay. So kinetic energy depends on speed. What speed you see? Okay. So it depends on observer. Kinetic energy depends on observer. Remember this. Okay. Kinetic energy depends on observer. Formula is half mv square. Okay, fine. But potential energy depends on position and configuration. So position and configuration. Okay, so it does not depend on speed. we'll discuss more on this. Okay, potential energy. What is mechanical energy? Mechanical energy is note down. Mechanical energy, note down topic. Mechanical energy. It is the sum of potential energy and kinetic energy. Note down. Mechanical energy. Mechanical energy. Mechanical energy is the sum of potential and kinetic. Okay, mechanical energy, potential and kinetic. Kinetic energy always positive. Kinetic energy always positive because how to calculate kinetic energy? Half m v square. Mass is always positive. Mass and v square is positive. Correct? So kinetic energy positive. Correct or not? Potential energy can be positive or negative or zero also. Note down. Potential energy can be positive or negative, understood, or zero. Potential energy can be positive, negative, or zero. If it is negative, it will be like this minus 2 joule, correct? If it is positive, so plus 2 joule, right? Are you getting? Just remember this. Potential energy can be positive or negative, but kinetic energy is always positive. And the sum, what is the sum? Mechanical energy. Suppose potential energy is minus 3 joule, kinetic energy is 1 joule. So what is the mechanical energy? Minus 2 joule. If potential energy is 4 joule, kinetic energy is 2 joule. So what is the mechanical energy? 6 joule. So mechanical energy can be positive, negative, correct? So mechanical energy can be positive or negative. Remember, potential energy can be positive, negative, mechanical energy can be positive, negative, kinetic energy always positive. Kinetic energy positive. What do you mean by potential energy? We'll discuss more. Kinetic energy, if speed is there, so kinetic energy is there. Fine. What is potential energy? So you see this object, this object. So I'm moving this object like this. Okay. So I'm doing work. A block is raised. A block is raised like this. A block is by raised through height h. A block is raised through height h. This is the block initially here. Now it is here. So how much height h? It is raised through height h. Initially block is here. Now the block is here. Okay. So what is the work done by gravity? Tell me. What is the work done by gravity? Minus mgh. Very good. And slowly, it is raised slowly. A block is raised through height h slowly. Okay, like this. Slowly, I am taking it. Slowly, like this. Slowly. So speed is always zero. You can say speed is always zero. Speed is always zero. Speed is always zero. So what is change in kinetic energy? What is change in kinetic energy? Zero. Speed is always zero. Slow, very slow. Slowly, I am taking like this. So what is the total work done? Total work done means change in kinetic energy. So what is total work done? Zero. But gravity work done? Minus mgh. So how much my work done? How much external work done? Total work done zero. So how much is my work done? mgh. Correct? So gravity is doing negative work. External work done is positive. So external force is doing positive work. And gravity is doing negative work. So potential energy increases. Okay, remember. Note down. Potential energy increases. So when potential energy increases, when external work done is positive. and gravity work done is negative. So potential energy increases when gravity do negative work, external agent do positive work. Okay, so external agent is doing positive work, so potential energy increasing. So we have a formula. What is the formula? Increase in potential energy is equal to external work or minus of work done by gravity. You see here, gravity and external, what is the relation? Negative. W external is equal to minus of work done by gravity. Okay, so delta U is external work done. Okay, understood? Clear? Just remember this. Okay, change in potential energy is external work done, same as minus gravity. Okay, just one numerical I am giving. If gravity is doing 100 joule work, gravity is doing 100 joule work, find increase in potential energy, or better I will write change, find change in potential energy. Tell me, find change in potential energy, gravitational potential energy, find change in gravitational potential energy. If increase in if gravity is doing positive work, tell me, use this formula delta U. What is the delta U? Minus of gravity work. So I am asking, change. So delta U is equal to minus of work done by gravity. What is work done by gravity? 100. So minus 100. Delta U is minus 100. Okay. Example, suppose the same block I am moving down. Now same block is moving down like this. So displacement is where? Downward. Displacement is downward. So gravity is doing positive work. Mg downward, displacement downward. So gravity is doing positive work. Okay. Mgh. External agent is doing negative work. External agent is doing negative work. Okay, clear? If gravity is doing positive work, change in potential energy is negative. Gravity is doing positive work. Okay. Okay, fine. So potential energy is related to gravity. If gravity is doing positive work, uh, delta U is negative. Remember, delta U is negative. Now spring potential energy, spring potential energy. Spring potential energy. So yesterday we discussed one formula. What is the formula for potential energy of a spring? What is the formula? Half k x square. Okay. Okay, fine. Actually, this formula is also delta U. Change in potential energy. How we are getting this change in potential energy is equal to minus of work done by spring. Like here you see, what is the formula for gravity? Change in potential energy is minus of work done by gravity. And here also potential energy change in potential energy is minus of work done by spring. And what is the formula for work done by spring? Minus k by 2 x2 square minus x1 square. So now if we put here, it will become k by 2 x2 square minus x1 square. Okay, so note down. So how we are getting this formula? How to get this formula? What is the meaning of this formula? How to get this formula? See, if you put x1 equal to 0, if x1 is equal to 0, x2 is equal to x, then what is delta U? Tell me. Half kx square, correct? If x1 is 0, it means initially spring is relaxed. So initially spring is relaxed. If initially spring is relaxed and finally elongation is x or compression is x, so how much potential energy will increase? Half kx square. So this is increase in potential energy. This is increase. Okay, you observe this formula. We are doing increase. Increase in potential energy is minus Wg. Increase in potential energy is half kx square. Okay. So this is the potential energy. What do you mean by zero potential energy? What is zero potential energy? What is the meaning of zero potential energy? So for spring, note down. For a spring, when no elongation, natural, for natural state, when spring natural state, what is the potential energy? Zero. Okay, remember this. Relaxed. Relaxed state potential energy zero. Potential energy of spring is zero when relaxed. Okay, clear? What do you mean by zero gravitational? In gravitational, what is the meaning of zero? Zero potential. We know the formula for delta U. Delta U is minus mgh or plus mgh. Okay, will like minus of work done by gravity. But what is zero? Zero potential energy. What is the meaning? Ground. Okay, so it is assumed. Note down. Meaning this is for spring. Okay, this is for spring. Zero potential energy of spring. What is the meaning of this? Relaxed. And zero gravitational potential energy means zero gravitational potential energy. Meaning of this, you can say ground level. Okay, ground level. Ground level is generally it is zero potential energy. Okay, understood? Are you getting? Ground level is zero, and you can assume any ground level. The ground level can be this. Ground level can be this. Okay, it is up to you. Which level you are selecting ground level? Table surface can be ground level. Okay. So what is ground level? It is assumed. It is assumed. Okay. Ground level is assumed. Ground level means what is the potential energy? Zero. So suppose this is the ground level. Suppose this is the ground level. This is the ground level. So at this level, what is the potential energy? Zero. If you go to this level, h height, if you go to h height, what is the potential energy here? Plus mg, increase. If you go below ground level, what is the potential energy? Minus mgh. Okay, remember this. So for ground level, potential energy is zero. If you go above ground level, potential energy becomes plus mgh. If you go below ground level, potential energy becomes minus mgh, right? Like suppose, give me any boxes there. Okay, so this is the ground like this. So if I hold the bottle like this, the center of mass is here. You can assume. If you hold the bottle like this, center of mass is here. Now this is the ground level. This is the ground level. Now in which case more potential energy? Standing or sleeping? Standing, where is the center of mass? Here. So what is the height of center of mass? Half. Now where is the center of mass? Radius. It is circle, right? So where is the center of mass? Height. radius. Okay, are you getting or not? So potential energy is more in this case. Okay, height is more. So when potential energy is more, suppose this is the ground level. So this is the ground level. So when potential energy is more, tell me. Suppose a student is standing. Student is standing. Suppose center of mass is here. The height of center of mass is h1. So what is the potential energy of this student? This is zero level. Ground level is zero level. So what is the potential energy of this? mgh1. Now the same person is sleeping. Same person is sleeping. Okay, tell me. Now almost it is on the zero level. So what is the potential energy now? Zero. Okay, clear? So h height above means mgh. Now you answer this. Block of mass 1 kg is lowered down by 2 meter. Block of mass is lowered down by 2 meter. Find delta U. First you answer this. Tell me what is the answer. Quickly you answer. Delta U is positive or negative? It is lowered down. Potential is increasing or decreasing? Decreasing. So initial level you can take 0. Initial level you can take 0. Now you are going h down. So what is the new potential energy? Minus mgh. Correct? So what is change in potential energy? Final minus initial. What is u final? What is u final? Minus mgh. What is u initial? So minus mgh minus 0. Okay, u final minus u initial. So what is delta u? Minus mgh. Okay, clear? So initial level you can take minus. Okay, let's do one more question. A block of mass 1 kg lowered down by 2 meter. So what is the answer? Minus 1 into 10 into 2. So what is the delta u? Minus 20. Okay. Suppose there is a rod. Initially the rod is standing. So center of mass is at what height? L by 2. Now it is lying. The same rod is lying here. Center of mass is here. This is center of mass. Center of mass. So what is, now this is 0 level. This is 0 level. So what is the potential energy? What is the potential energy now? mg L by 2. Okay, this is the center of mass. So for rod you consider center of mass. Okay, what is the final potential energy? 0. So what is change in potential energy? 0 minus mgl by 2. Okay, clear? So suppose this rod is lying here, you want to make it standing, you have to do external work, right or not? Like this object, right now this object is lying, now you want to stand it like this, correct? So you have to do external work. Why you have to do external work? Because potential energy will increase. To increase potential energy, you have to do external work, because external work done is equal to delta U. So to increase potential energy, you have to do external work, positive external work, correct? Are you getting or not? And to decrease potential energy, like this, here to here, potential energy decrease, so negative external work. Like this is negative external work. I'm moving it like this. Negative external work. This is positive external work. Okay, just memorize this formula. Okay. Okay, fine. Good. Next, let's do one question on chain. Okay, note down hanging chain. Hanging chain. Hanging chain from table. Hanging chain from table. Hanging chain from table. So suppose this is the table. Now table you can assume zero level. This is zero potential energy level. Zero potential energy level. It's a table. Okay. Now chain is there. Suppose this is the chain. This is the chain. Okay, clear. So it is a hanging chain. So what is the length of the chain? L. What is the mass of the chain? M. Now you are standing here. The person is standing here. Okay. So it is holding this end. It is holding it like this and pulling it. It is pulling it. So person is pulling chain. Person is pulling chain, and where to keep? Where to put? On the table. Okay, on the table. So how much work is done by person? That is the question. How much work is done by person? Person is pulling chain and put it on table. Put it on table. So what is the work done by person? So work done by person. What is the work done by person? Are you getting? So this chain is there. So where is the center of mass of the chain? Center of mass here. So this is the zero level. So what is the distance of center of mass? L by 2. So initially center of mass is here. Center of mass. Center of mass is also known as gravity. Center of gravity. Center of gravity, you can say. Generally it is at the center. You just, for time being, you just remember it is at center most of the time. Mostly where is the center of mass or center of gravity? At the center, like this pen. Where is the center of mass? Here. Okay. Mostly. Okay. So chain is there. So where is the center of mass? Here. L by 2 distance. Now whole chain will be here. So another diagram you draw. Now whole chain is on the table. So where is the center of mass? Here. Are you getting? So what is initial potential energy of the chain? For chain, what is the initial potential energy? Initial potential energy, tell me, plus or minus? Minus. Minus m g h. H is L by 2. Very good. And what is the final potential energy? 0. Final potential energy 0. So what is delta U? What is delta U? Correct. mgl by 2. U final minus U initial. 0 minus mgl by 2. Okay. So plus mgl by 2. Delta U is plus mgl by 2. So, but what is the question? Work done by person means external work done. And what is the formula for external work done? External work done is equal to delta U. External work done is delta U. Remember, external work done is delta U. So delta U is mgl by 2. Okay, clear? Remember mgl by 2. Your answer, what is your answer? mgl by 2. This is your answer. Okay, clear? MGL by 2. So the chain is hanging chain is there, table is there. Now you're pulling it like this, you're pulling it and put it here on the table, put on the table. So how much actual work you are doing? MGL by 2. Okay, understood? Now suppose chain is not there, bucket is there or block is there. Suppose this is the bucket or block and here is a string. Mass of the block is M and the length of the string is L and the same person is there. It is holding this string and pulling the string like this. Now what is the work done by person? Tell me. So this is 0 level. So what is initial potential energy of block? It is not chain. It is not chain. It is a string. It is a string. Massless string. Massless. String is massless. So what is the mass of this line? 0. What is mass of this block? M. So what is initial potential energy? Minus MGL. And what is final potential energy? It is keep here. 0. So what is change in potential energy? MGL. So U final minus U initial. 0 minus MGL. So it is MGL. Okay, clear? So what is the external work done? Delta U. So this is MGL. Okay. So you observe the difference. Here we have block, small block. Okay, small block is there. The mass of a small block is M, and then string is there. So you are pulling the string, and the block you will keep where? On the table, surface. So through what height you are raising it? Through what height? L, correct? Through L height you are raising it, putting on the table. So you're doing external work done. What is the external work done? MGL. Okay, clear? Now here you are doing what? Chain. Now chain is continuous. Here to here, everywhere chain is there. Okay? So you have to take center of mass. So center of mass, what is the height of center of mass? L by 2 below. Understood? Now center of mass you are taking from here to here. Okay, clear? So MGL by 2. So what is easy to do? The block or chain? What is work done is less? Where? Chain. Work done is less. Okay. Okay, clear. Okay, fine. Now you solve this next. Now part of the chain is there, not whole chain. So suppose this is the table. Now like this. Here what is the situation? Here whole chain is there. What is this? What is this? Whole chain L hanging. But here part of the chain. Part of the chain. Okay. So let 1 by eta times length. 1 by eta times length is hanging. 1 by eta times length is hanging. So what is the length of this chain? This part, tell me. Hanging part, tell me. What is the length of hanging part? Correct. Suppose half chain is hanging. Half chain is hanging. So it means what is eta? 2. Okay. That means L by 2 is hanging. Understood? If 1/3 is hanging, 1/3 hanging. So what is eta? 3 means L by 3 is hanging. Understood? If 1/4 is hanging, if 1/4 is hanging, So what is eta? 4 means L by 4 is hanging. L by 4 is hanging. Okay, understood? Clear? Note down. Now this is the table surface. This is the table surface. Okay, clear? Zero level. What is the potential here? Table surface. What is potential? Zero. Zero. Good. Zero. Now this is the resting part. We don't care about this. Hanging, you see, hanging. What is the length of this? What is the length of this? L by eta. So where is the center of mass? Center of mass is here. This is the center of mass. So what is the distance of center of mass? Tell me. This is L by eta. L by eta. So what is the distance of this? Half. L by 2 eta. Are you getting or not? If this is L by 2, so what is this? L by 4. If this is L by 3, so L by 6. If this is 1 meter, so this is 0.5 meter, correct? So this is L by eta. Total length is L. Total length is L. But how much is hanging? How much is hanging? If half is hanging means how much is hanging? L by 2 is hanging. If 1/3 is hanging means how much is hanging? L by 3. 1/4 hanging means how much is hanging? L by 4. Understood? Clear? So if 1 by eta times is hanging, so L by n is hanging. So this is L by n, so this is L by 2n. Understood? So now U initial, tell me what is a U initial? In this position, what is the potential energy of resting part? 0. So you can call it A, B, C. AB is resting part and BC is hanging. So what is the potential energy of resting part? 0. What is the potential energy of hanging part? Hanging. Minus m or mass of this only, not total mass, only mass of this. What is the mass of this? Note down. What is the mass of this? M by eta, correct? If this is L by 2, so what is the mass of this? M by 2, total is M, total 1 kg. So what is the mass of this? L by 2, suppose half kg, okay? M by 2. If L by 2, so M by 2. L by 3, so M by 3 mass. So L by eta, so what is the mass of this? M by eta, correct? G, H, L by 2n eta, okay? And what is the potential energy of resting part? This is the resting or table, or you better use right the table. So on the table surface, what is the potential energy? 0. Hanging part is this. So what is the initial potential energy? Minus mgl by 2 eta square, correct? And finally, what will happen? Tell me finally where the whole chain is where? On the table. Finally, whole chain is on the table. Finally, whole chain is on the table. So finally, whole chain is on the table. What is the U final? This is 0 level. So what is U final? Center of mass is here. So what is U final? 0. Okay, U final is 0. So what is change in potential energy? What is change in potential energy? U final minus U initial. Final minus initial. U final 0 minus U initial minus mgl by 2n square or eta square, minus minus plus. So mgl by 2 eta square. Okay, this is delta U. So what is the work done? External work done. Yes. External work done in delta U same. So mgl by 2 eta square. Okay. External work done is mgl by 2 eta square. Note down. So solve this question now. Solve this. You can memorize this formula. Okay. Formula diary you write down. This is the formula mgl by 2 eta square. So note down. Initially question. Initially one third length of smooth chain hanging. Initially one third length is hanging from table initially one third length is hanging from table. Find external work done to put whole chain whole chain on table. To put whole chain on table. To put whole chain on table. How much part is hanging? L by 3. Correct. Good. L by 3 is hanging. So what is the formula for work done? mgl by 2 eta square. So what is the answer? mgl by 2 into how much is hanging? L by 3 is hanging. So what is eta? 3. Okay. So 3 square. So what is the answer? Tell me. 18. Correct. mgl by 18. Okay. Clear? Clear? Understood? Difficult, right? Easy. How easy? Okay. So external work done is delta U. Okay, fine. External work done is delta U. Okay, clear? Finish. So this is done. So this chain is finished. Okay, fine. Now next you write down. We can solve potential energy of a spring. Okay, fine. Next topic you write down conservation of mechanical energy. Note down. Conservation of mechanical energy. Conservation of what do you mean by conservation? What do you mean by conservation? So conservation means what is conservation? Tell me what is conservation? Not change. Correct. Good. Not change. Conservation means not change. Okay. In our daily life, you hear forest conservation, right? What is forest conservation? What is forest conservation? Tell me. Huh? What is forest conservation? Number of trees should be constant. What is forest conservation? Number of trees should be constant. But to cook food, we need wood, fire, cooking food. So number of trees constant. Wood is used, correct? Furniture is there, wood is used. So trees are cutting, but every year how many trees you are cutting? Suppose 100. How many trees you should grow? 100. Are you getting or not? How many trees you are cutting down? Equal number of trees you should also grow. It means your number of trees are constant, that is known as forest conservation. Water conservation, what is that? What is water conservation? Suppose there is a well. You know, understand well? Well, you know, right? Suppose water is there. Suppose you are taking one bucket of water. One bucket of water you are taking. Now you should make sure you are putting one bucket back. Okay? But you don't put. Rain will come, correct? Rain will fill it. Understood? So that is water conservation. How much water you are using? Equal water should come again. That is water conservation. Understood? Now, what is mechanical energy conservation? What do you mean by mechanical energy conservation? Mechanical energy is constant. Now, what is the mechanical energy? Tell me. What is mechanical energy? Kinetic energy plus potential energy. If potential energy is decreasing, so kinetic energy must be increasing. If potential energy is increasing, so kinetic energy must be decreasing. Suppose potential energy increased by 1 joule, so kinetic energy must decrease by 1 joule. Okay, understood? That is known as conservation of mechanical energy. Okay, understood? Okay, see, conservation of mechanical energy. If one mechanical energy is increasing, so other mechanical energy is decreasing. Kinetic energy is mechanical energy, potential is mechanical energy, both are mechanical energy, total mechanical energy. Okay, one is increasing, other should decrease. Understood? Okay, so how is it possible? How? So let's take very basic example. In gravity, like for example this, what is decreasing? Which energy is decreasing? It is going down. So which energy is decreasing? Potential energy. But you see increase in kinetic energy? Yes, correct. So in gravity, block is released from rest. Released. Block is released from rest. From height h. From height h. Above the ground. Above ground. Ground means zero level. Ground means zero potential energy. What is the potential energy level? What is the potential energy of ground level? Zero. Okay, so initially where is the block? Suppose this is the ground level. Suppose this is the ground level. Initially where is the block? At what height? H. So what is the potential energy here? mgh. Now it is released. Now it is released. So block is released from rest from height h above the ground. Now question is, find its speed. Find its speed when it hits ground. Find its speed when it hits ground. Now it is coming down, coming down, coming down. So it will hit the ground. So what is the speed? So you can say uh, decrease in potential energy. What is the decrease in potential energy? Uh, how much potential energy decrease? What is the initial potential energy? mgh. What is the final potential energy? Zero. Ground level. Are you getting or not? This is ground level. My hand is ground level. So what is the decrease in potential energy? Okay, okay, forget about decrease. You tell me change. What is the change in potential energy? Minus mgh. Good. U final minus U initial. So 0 minus mgh. Okay, so minus mgh. So delta U is negative. So delta K should be, tell me, what is delta K? If potential energy is decreasing, so kinetic energy increasing. So delta K should be plus. So plus mgh. Okay, delta K is plus mgh. Okay, potential energy decreasing, so kinetic energy increasing. Okay, clear? So note down, delta U plus delta K is equal to 0. This is the formula. Delta U plus delta K is equal to 0. So block is released from height h. So loss, potential energy is loss, kinetic energy is gain. Understood? Kinetic energy is gain, potential energy is lost. Loss in potential energy, gain in kinetic energy. Okay. So delta U plus delta K is 0. Suppose delta U is positive, so delta K is negative. If delta U is negative, delta K positive. So total is 0. Delta U plus delta K is 0. What is the formula for uh, uh, delta K? Now come here again. So delta K is equal to mgh. Now what is delta K? Half m v square minus 0 square, initially rest. So what is the answer? Half mv square is equal to mgh. Cancel. So what is the v? Square root 2gh. Okay, square root 2gh. So block is released from rest. Block is released from rest. So when it is hitting the ground, what is the speed? What is the speed? Square root 2g. Okay, clear? So this is because of conservation of mechanical energy. Now one more point you can write. Delta U. What is delta U? U final minus U initial. And what is delta K? K final minus K initial. That is equal to 0. Now final here. Initial you take right side. So U final plus K final is equal to U initial plus K initial. Understood? U final plus K final is equal to U initial plus K initial. So this is final mechanical energy and this is initial mechanical energy. Okay, clear? Note down. Note down. So question is block is released from height h from rest. With what speed it will hit the ground? With what speed it will hit the ground? So you can use the same formula again. What is U final on the ground? What is U final? 0. Kinetic energy half mv square. U initial at height h. What is U initial? mgh. Initially at rest, what is kinetic energy? 0. So you can solve it. Okay, clear? Note down. So half mv square is equal to mgh. Half mv square is equal to mgh. Same thing in inclined plane. Suppose initial height is h. Now block is released from here. This is the block. It is a smooth. Okay, smooth surface is there. Can you tell me what is the speed here? Tell me. What is the speed here? Sliding. So what is U initial here? U initial. This is 0 level. Okay. If this is 0 level, so what is U initial? mgh. What is K initial? It is rest. So K initial 0. What is U final? Here 0. What is K final? Half mv square. Now same formula you will get. Okay, same thing. U initial plus K initial is equal to U final plus K final. So mgh plus 0 is equal to 0 plus half mv square. Okay, clear? So note down. Only see the height. Pendulum Initially string is horizontal. How is the string here? We have pendulum here. So what is the speed? What is the string? How is the string? How is the string here? How is the string? Horizontal. Now release it. Now release it like this. So when it is coming vertically, what is the speed? When the ball is coming here, what is the speed? Tell me. Length. Length of the string is L. Length of the string is L. So you can take this is zero level. This is zero level. You can take zero level. So what is initial potential energy? What is initial potential energy? Zero. What is initial kinetic energy? What is initial? What is initial kinetic energy? Zero. Now what is U final? Below. Below. How much below? Correct. So U final is minus mgl. From zero level, how much below you are? L level. So minus mgl. What is K final? Half mv square. Correct. So U final plus K final, U final plus K final is equal to U initial plus K initial. What is the U initial? U final, how much U final? Minus mgl. K final, half mv square. U initial, 0. K initial, 0. So half mv square is equal to mgl. Cancel. So what is V? Square root 2gl. Okay. So suppose this is the ball. Now length. This is the length. Okay. Length L. I am holding like this. Now release like this. Okay. So what is the speed when it becomes vertical? Square root 2gl. Okay. Clear? Understood? Tension is not doing any work. Don't worry about tension. Okay. This is tension. What is the direction of tension? Tension is along a string, and velocity is tangential. Tension and velocity, what is the angle? 90 degrees. So tension is not doing work. Only gravity is doing work. Tension work is 0. Tension work is 0. Only gravity work. Okay. Only gravity work. Only gravity work. Okay. So why this ball is coming down? Why this ball is coming down? Because of gravity. Because of gravity. Okay. Last. Initially it is making theta with vertical. So like here, what is the angle now? Theta with vertical. When it is horizontal, what is theta with vertical? With vertical, what is theta? 90. So when released from 90 degree, okay. Now it is released like this. Okay, understood? So you can take this as 0 level. You can take this as 0 level, no problem. This is 0 level. Are you getting? And the ball will come like this. Ball is coming like this. So what is the speed here? V. So this is 0 level. This is 0 level. So tell me what it is released from rest. It is released from rest. It is released from rest. Okay, like this. So what is initial potential energy? Tell me. 0. And the initial kinetic energy? Initial kinetic energy? 0. Rest. Okay. Now what is final potential energy? Now you have to do some geometry. What is the length of the string? L. So how much is this length? This length? Cos theta or sin theta? Cos theta. Suppose this is L, this is thetas, this will be L cos theta, okay. This is L sin theta, this is L sin theta, this is L cos theta. So this is L cos theta, this is L cos theta, and this is total L. This is L. So how much is this? How much is this? L minus L cos theta. L minus L cos theta. So this is 0 level. This is 0 level. So how much height you are going further from here to here? How much height below you are going? L minus L cos theta. Okay. So what is the final potential energy? Minus mgh. From this level to this level, how much you are going? L minus L cos theta. So what is final potential energy? Minus mg L common 1 minus cos theta. And what is final kinetic energy? Final kinetic energy half mv square. Okay. So what is the answer? Use U initial plus K initial is equal to U final plus K final. So U initial is 0. This is 0 level. 0 level, you can take any level as 0 level. Okay, note down. You can take any level as 0 level. Any level you can take as 0 level. Okay, so I am taking this as 0 level. So what is the potential here? Minus mgh. Minus mgh. Okay, substitute. So U initial plus K initial is equal to U final plus K final. Understood? So sorry, K initial is 0. Okay, K initial is 0. K initial is 0. So what is the answer now? So mv square by 2 is equal to mgl into 1 minus cos theta, cancel. So you will get v square is equal to 2gl into 1 minus cos theta. So you will get v is equal to square root 2gl into 1 minus cos theta. Okay, clear? Okay, done. So just remember this, okay? But memorize the formula. Memorize the formula. What is the initial angle from vertical? What is the initial angle from vertical? Theta. Now the ball is released. Now the pendulum is released. So what is the velocity here? Okay, formula is this. The square root of 2gl into 1 minus cos theta. Okay, if theta is 60 degree, so what is the v? Square root 2gl 1 minus cos 60, 1 by 2. So 1 minus 1 by 2 is 1 by 2. So 2gl into 1 by 2, 2 to cancel. So what is the speed? Root gl. If theta is 90, so v will be square root 2gl 1 minus cos 90. Cos 90 is, what is cos 90? Cos 90 1 or 0? 0. Cos 90 is 0. So root 2gl. Okay, clear? Just remember this formula. Okay, we'll continue. Okay, now we'll take break.